We are making a saline solution in science class. 100 milliliters of a 50% saline solution is obtained by mixing a 40% saline solution with a 60% saline solution. How much of each must you use? So let's draw our boxes. So we're mixing a 40% solution with a 60% solution to obtain a 50% solution. And we know that we want 100 milliliters of that 50% solution. We don't know how much of the 40%. We don't know how much of the 60%. So now to set this up, we would have x plus y equals 100. And then we would do 40% times x, which would be 0.4x, plus 60% times y, which is 0.6y, equals 50% of 100 is 50. So that is how number 1 is set up. So now all you need to do is you need to solve either using elimination or substitution, and then answer the question, how much of each must you use? Number 2. You are making 10 tons of concrete, that is 40% cement, by mixing 20% cement with a 70% cement mixture. How much of each must you use? So again, making our boxes. We want to make a 40% cement mixture, and we want 10 tons of it. To do this, we're going to mix 20% with 70%. And again, we don't know how much of each, so we're going to let our variables take over here. So our first equation comes from the bottom numbers. X plus y equals 10. And our second equation comes from multiplying 20% times x, so that's going to be 0.2x plus 70% of y, so 0.7y, and we're going to multiply 40% times 10, which is going to give us 4. So here is our system, and then you need to solve either using elimination or substitution. And again, they want to know how much of each must you use. Number 3. A merchant has 20 pounds of an $8 per pound tea. How many pounds of a $4 per pound tea should he add to the $8 per pound tea to get a tea mixture that is worth $5 per pound? So there's quite a lot going on in this problem. So we're trying to get a $5 per pound tea. We have an $8 per pound tea, and we have a $4 per pound tea. So we know that this $8 per pound tea, we have 20 pounds of it. So 20 goes under the 8. We do not know how much of the $4 tea we have, and we do not know how much total amount of tea we have. So this equation, the bottom one, comes from the bottom problem. So 20 plus x equals y. Oops. And then again, our second equation comes from multiplying 8 times 20, 4 times x, and 5 times y. So 8 times 20 is 160, plus 4x equals 5y. And again, this one would probably be best solved by substitution because it's already solved for y, but you could just as easily use elimination. And you want to know how many pounds of just the $4 per pound tea should be added. So the only thing we're really looking to solve here for is x. Number 4. When a plane flies into the wind, it can travel 3,000 miles in 6 hours. When it flies with the wind, it can travel the same distance in 5 hours. So this is one of our distance, rate, and time problems. So we're going to make our table. So we're flying into and with the wind. So when he flies into the wind, he can travel 3,000 miles in 6 hours. When you fly with the wind, it travels the same distance in only 5 hours. So this one's quicker, which means this one should be our adding and this one should be our subtracting. So find the rate of the plane in still air and the rate of the wind. So we're going to have the plane, and when you go into the wind, you have to subtract the wind rate. And when you go with the wind, you have to add the wind rate. So this system would be 6 times P minus W equals 3,000, and 5 times P minus W equals 3,000. Now it is important to know whether you're going into or with. Is it working against you or is it helping you? Okay, if it's helping you, it's adding. If it's going against you, it's going to be subtracting. And it's important to know this because otherwise you'll get some numbers that don't quite make sense, and when you go to answer the question, it won't be correct. So again, you have a choice. You can distribute, or you could divide both sides by 6 for this one and get P minus W equals 500, and then divide this one here by 5 and get, oops, that should be plus. P plus W equals 600. And then this one be set up beautifully for elimination. Number 5. When Dwayne drives his boat to work upstream, the trip takes 45 minutes. Okay, as soon as I see that we're going upstream, this is a distance and rate time problem. Okay, so upstream, the trip takes 45 minutes. When he comes home downstream, it takes 30 minutes. The distance to work is 90 miles. So he's going the same distance to work and back home from work. So they don't tell you straight up that it's the same distance, but it's the same distance. So find the speed of the stream in miles per hour. So we have two rates here. We have the boat's rate and we have the stream's rate. Going upstream, the boat and the stream are working against each other. Going downstream, they're working together. So you're adding here. Going upstream, you're subtracting. They're working against each other. And again, the time is shorter because they're going faster. So here is our distance and time. Now we do need to be very careful in this problem. It does say find the speed of the stream in miles per hour. So this is miles, this is miles, but these are minutes. And we need those to be per hour. So 45 minutes is really 3/4 of an hour. And 30 minutes is really half of an hour. Okay, because otherwise we're going to get some sort of wonky answer at the end. So now our system is going to be 3/4 times b minus s equals 90. And then 1/2 times b plus s equals 90. Now again, you can distribute, or you could divide both sides, which in this case would mean multiplying by the reciprocal. So times 4/3, which would give you b minus s equals 120, if I've done my math correct. 3 goes into 90 30 times. 30 times 4 is 120. And then likewise here, multiply both sides by 2. Okay, so that would give us b plus s equals 180. And then from there, you could solve it like before.